All right, so the Chapter 7 test is tomorrow. Then on Friday, we're going to do an NWEA practice quiz with everyone, including you, including Zay, everyone. And what I'm going to do with the quizzes, or the NWEA, if you score, you beat either your spring or your fall score, whatever the highest is. I'm looking at that today, so I'll have that for you tomorrow. If you beat that by 1 point, I'm going to add a column with an NWEA quiz grade that'll give you a 90% on your quiz. Okay? If you beat it by 2 or more, I will put 100 in for your quiz grade. Okay? If as a class, you guys average 2 or more, so that means, someone gets 4 and someone else gets 0, average still would be 2, I'm going to be bringing baked treats in for the final. Okay? You don't have to take it, Tryon.
Okay. So, well, if there's an average, I'll bring some stuff because I don't have them.
Okay. So,
I won't bring them.
and not to toot my own horn or anything, but I do make some pretty good desserts. So, just saying. So, it's a double whammy. You get something for yourself, something for the class. So, by doing that, I'm not necessarily able to impart more information in your head, so you're not going to become smarter because I'm putting this incentive out there, but I'm hoping it'll encourage you to do your best on it because you want my food. Just saying. Just math. It's the math. Mm-hmm. It's a full-on math. You can do it. But you don't have to do English or reading or science or whatever, just math. Okay. Here we go. Of the 240 students eating lunch, 96 purchased their lunch. The rest brought a bag lunch. What's the ratio of students purchasing lunch to bringing a bag lunch? So on these questions, it's really important which number you're going to have go first. The number you're going to have go first in this case is the students purchasing lunch, which is 96. Okay, and I like to write them in fractions just until I simplify, and then I can put it as a ratio. And the students who didn't purchase lunch, how many are left? How do you do that? Just 240 minus 96, right? Now I'm going to simplify. What, 16? Does it go unevenly to both? 12? I know 12 does. 6 and 9. So something 24 probably went unevenly to both. 6 and 9. So this is 6, this is 9, which can be reduced to 2 over 3. 2 is first, 3 is second. Questions on that? Just ratios? Hopefully it's not too hard. The key there is just recognizing what they want you to put first. Okay? In a rectangle, the ratio of the width to the length is 4 to 5. If the rectangle is 40 centimeters long, find its width. Well, when I set this proportion up, I've got to make sure and put the width and the length in the right place. So 4 represents the width, 5 represents the length. I'm looking for width, I have length. Okay, then you just cross multiply, or a shortcut to cross multiplying if you're interested in it. If you can find how many times 5 goes into 40 evenly, 8. That same number multiplied by 4 is the missing number. Everybody follow that? You can cross multiply, but then you'll get the same thing. Okay, so it's something I do. It only works if this number goes into this one evenly. If it doesn't, you're going to have to cross multiply. But it's something to check because it does save a little time. You just figure what times 5 is 40, and that number times 4 is your missing number. Okay. I'm just full of all kinds of helpful hints today. Just ask the other classes, they'll tell you. Okay. A postage stamp, 25 millimeters wide, 40 millimeters tall, is enlarged to make a poster. The poster is 4 feet wide. Find the height of the poster. Same thing. Width is on top this time. Height is on bottom. One of the questions Nicole asked me yesterday, and it was a good question. We talked before about making sure that your units are the same. Well, it's important the units are the same in the ratio, not necessarily the proportion. As long as I'm okay with my missing value to be the same unit as this one, I can leave the unit. So I don't have to convert millimeters to feet, and I don't have to do feet to millimeters, okay? Because millimeters is here, and millimeters is here, it becomes unitless. So as long as feet are here, and my answer then I've got to remember is going to be in feet. Okay? Now, we can cross multiply right now. I would recommend simplifying your fraction first, making it 5 over 8. Right? Because then it's going to make your multiplication a lot easier. Now notice here, I could say 4 times what? 1.25 is 5. And what number times 1.25 is 8. But that kind of defeats the purpose of making it a little easier. So in this case, I may just cross multiply. This is 32 equals 5x. X equals 32 over 5, which is a little more than 6. 6.4, actually. Questions on that one? Guys are looking at those calculators like they're cell phones. I almost had to tell you to put your cells down and realized that it was actually a calculator. You're trying to do these problems ahead of time? Yeah, that's what I thought. Okay. Find the polygon that's similar to ABCD. Where is ABCD? Here. I don't know why there's a letter by it. We're trying to find one that's similar to this one. So it looks to me like this is 1, 2, 3, 1 to 3. This one?
I don't remember doing that.
Maybe I took it out of yours because it was so vague. I don't know. This one shouldn't have been a letter. This is the one you were trying to use as your triangle or your polygon, and then picking A, B, or C to find the one that matches. Okay, let's move on to 5. If PQR is similar to STU, remember similar is just the one squiggly, congruent is the squiggly with an equal sign. Similar. And we've got to remember the order matters. Okay? So P corresponds to angle U. This angle P corresponds to S. This angle is S. Q corresponds to T over here, and R corresponds to U here. We're trying to find the value of X. Well, S is 123. T is 22 because it corresponds to this one. 123 plus 22 is 145. So I know that this angle must equal, what, 35 degrees? So I know 5x equals 35. X is equal to 7. Make sense? Don't rush through it and automatically think 22 is 5x. Make sure that you're figuring out what angles correspond and then match them up that way. That'd be an easy mistake. Okay. All right, next one, these are also similar. We want to find the value of x. These are actually oriented in the right manner, so I can just say A goes to E, B goes to F, C goes to G, D goes to H. So I know this side and this side should be in a proportion. So I could say 16 over 10 equals 30 over x minus 4. I would simplify this first, make it 8 over 5. Now I cross multiply 150 equals, distribute 8x minus 32. Make sure that you're distributing the 8 to both terms. Add 32. Divide by 8. What is that? Do they give us a drawing on this one? No. So on a problem like this one, draw your triangles so that you can correlate what they're giving you and label them. Okay, AB is 18. BC is 12. LN is 9. LM is 6. What's the scale factor? Well, to do the scale factor, all I need, if I know the triangles are similar, all I need is one side of each, corresponding side. So if I do scale factor of ABC to MLN, 18 to 9, am I getting bigger or smaller? Smaller, so my scale factor should be less than 1. So that would be a good way to kind of check your work when you're done. Because you might be tempted to say it's 18 to 9, which is 2 to 1. But if I'm going from ABC to LMN, my side's getting smaller. So it's actually, it should be 1 to 2. ABC, LMN, but I don't have a choice of 1 to 2. I think it's 1 to 2, but I guess 2 to 1 is what they wanted. I don't know. Does that make sense? I think it should be smaller than 1 because you're getting smaller from A to B. I mean, from that triangle to this one. But if there's a problem like that on the test, I will take what I think into consideration. Okay. All right. Name the theorem or postulate that can be used to prove that these two triangles are similar. Well, anytime you're given that they're parallel lines, always think angles. Two parallel lines with a transversal isn't going to tell me anything about side lengths. But I am going to be able to figure out angles that are equal. Okay, so I know my answer's got to have an angle in it. It's not going to be side, side, side. What are my choices with similar triangles? Angle, angle. Side, angle, side, 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 side. That's it. Angle, angle, as long as two angles are congruent to the other two. Side, 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 angle, side. Okay? So if I look here, if I'm trying to prove that they're similar, this angle and this angle are congruent. This angle and this angle are congruent. Side, angle, angle. I don't know anything about the sides. They didn't tell me any kind of ratio to the sides to know anything. But I do know I've got angle, angle. Okay. Letter A. Side, side angle is not even a thing. Refer to the figure below to answer the following questions. So I could use side, angle, side here. That might be the easiest. Instead of showing all three proportions are the same, or three ratios, I would only really need to show two, these two, and to these two. Right? Because this angle is congruent to this one. So I can use side, angle, side. Okay, so let's look at the proportions. If these two are equal, it would either have to be 15 over 3 and 18 over 2.5, or 15 over 2.5 and 18 over 3. Do you see the difference? I don't know whether the triangles are similar exactly the way that they've been written, that it's PRQ and SRT, or is it PRQ and TRS? I need to figure out that order. So I'm going to test both ratios, or both proportions, and see which one's true. Okay. 15 over 3 is 5. What's 8 over 2.5? It's going to be bigger than 6, isn't it? Because 18 over 3 is 6. Seven. Okay. So is 5 equal to 7.2? So it's not this ratio. 15 over 2.5? 18 over 3? 6. Okay, so this is it. So that means this piece corresponds to this one, right? So if I draw my triangles separately, which I would recommend doing, and just label this first one however you want to, when I label the second one, P corresponds to T, Q corresponds to S, and R corresponds to R. If I label it, now I'll be able to answer the question much easier. So let's look at the choices. PQR should be to TSR, right there. Okay? It might be really easy to say it's PQR and STR. You've got to check those ratios and make sure they're the same, though, before you can assume they're similar. Most of the time, when you have crossing lines like this, it's usually the flip, like we found it to be. That this angle corresponds to this one, and that one corresponds to that one. But always check it. Does that make sense? Okay. You aren't going to tell me if it doesn't, so I don't know why I ask. Okay. Now find the value of x. Well, PQ corresponds to TS, right? So now I can just say 4x equals 2. So x is 2. It's not even a choice. Oh, I've got to do ratios. They're not congruent, they're similar. Nobody catches me because nobody cares, but just telling you, that's a simple mistake I just made that you might make too. If they're similar, what did we decide the ratio was? 6 to 1, right? So let's go 6 is to 1 as 4x is to 2. Okay? They're not congruent. They're similar. 12 equals 4x. X equals 3. Now I can find an answer. Now, if one of those answer choices had been 2, I would have circled 2 and moved on, and I would have been wrong, right? So make sure you understand the difference between congruent and similar. With similar, you've got to set up ratios. You can't just set them equal to each other. All right. A 24-foot flagpole casts a 20-foot shadow. There's my shadow. There's my flagpole. At the same time, so I'm going to draw this triangle, the building next to it casts an 85-foot shadow. So I have another building that's 85 feet and then some other shadow. And this whole thing is x. Let's see, someone's watching. Okay, why are these triangles similar? What reason? It's not one of the questions. I just want to know what you think. I still didn't hear you. Why are the triangles similar? What of the 3 reasons can you tell on this one? Angle. Okay, because that's a 90, right? A building and its shadow is going to be a 90. This is the same angle here and here. It's the angle of elevation of the sun, okay, which is going to be the same. If the sun's in the sky shining down at the same exact spot, whether you're the building here or the tree here, you're getting the same angle. Okay, so we're going to say these 2 triangles are similar because of angle. And now I can go ahead and make proportions to solve. Okay, so I know 24 is to 20 as x is to 85. Right? Simplify this first by 2, right? 12 over 10, no, by 4, 6 over 5. Yes. What's 85 times 6? 510. Divided by 5 is 12? No. 5 goes into 5 1. 5 goes into 10 twice. That's not right, though. Huh? 102? No. I'm having math problems today. Okay. There it is. Luckily, the answer's up there. Okay. Number 12. Are these similar triangles, first off? Why? Yeah. That was one of the last lessons that we learned with the parallel transversals, one base and then one going through the triangle. Okay, so what can I do? What kind of ratio? Uh-huh. Mm-hmm. Okay. Everybody see that? Simplify 3/10. So 10x equals 105. Doesn't seem right. Yeah. Yeah. I'm telling you. Actually, I'm just doing this today to keep your interest, keep you engaged in class. I'm intentionally making errors so you catch them. Okay. I don't think you bought that. Anybody want to help me with that one? Okay. Find the value of x so that ST is parallel to PR. So this time it's the converse of this one. They're not telling us they're parallel, but we know if we can get the ratios to be the same, then they will be parallel. So that's all I have to do is find the value of x. So it's going to be 25 is to 5 as 4x minus 3 is to 3. Could I also say 25 is to 4x minus 3 as 5 is to 3? Yeah, doesn't matter. Eventually you'll end up cross-multiplying and getting exactly the same thing. 25 is to 5. Well, that's 5. So that's 15 is 4x minus 3. 18 is 4x. Hopefully the answer is a decimal. Otherwise, I've done math wrong again. Luckily. Okay, same thing here, except we don't have officially triangles. We just have parallel lines with the transversal. We still can create proportions from that. So I will just say 1/3 y plus 2 over 2y is to 6 over 9, which is 2 over 3. When I cross multiply then, 3 times 1/3 y is just y plus 6 and 4y. Everybody follow that? Subtract y. Y is 2. Mrs. Reader got one right. It's a miracle. Okay, if these two are similar, find the perimeter. Couple of ways to do this. There's a long way and there's a short way. I'll do both, but I want you to remember the shortcut to this. Okay? The long way is, first I figure out that xy is to KL, so it's 9 to 4. That's my ratio that I'm going to use. Okay? So if I want to figure out what this side is, well, that side correlates, YZ correlates to LM, which is 7. Cross multiply, solve for x, and I know this one. Do the same thing here, and I know this one. Add them all up, and I know the perimeter. That's the long way. The short way is to recognize that the perimeter of one triangle that's similar to the other is the same scale factor. So if I can find the perimeter of this one, I'm just going to use the scale factor that I figured out to find the perimeter of this one. Does that make sense? That's a little easier. Okay, so 4 plus 7 is 11, plus 9 is 20. The perimeter here is 20. So I know 4 is to 9 as 20 is to x. That's a lot faster than finding both of these sides and then adding those up. Follow? Okay. You can do it the other way if you want, but this is faster. 4x equals 180. 45. Follow? Just use the perimeter and the scale factor to find the new perimeter. You don't have to solve for all the sides. That's the point. Okay. In triangle ABC, if those two are similar, ABC, JKL, altitudes are BX and KY, find BX. Well, what's an altitude? It goes from the vertex down to the, not to the midpoint necessarily, just at a 90-degree angle. So that's a 90. So we should just be able to say 32 over 10 is to 6, or x over 6. 32 over 10, 16 over 5. 1, 9. Next one, this is the angle bisector. So when you have an angle bisector, you can make ratios between the sides of the opposite side that's been bisected and the legs. Okay, so 12 is to x plus 2, as 8 is to x. 12x equals 8x plus 16. 4x equals 16. X equals 4. What is the scale factor of the dilation of A to B? Did it get bigger or smaller? A is here, and then B is here. So bigger to smaller means the scale factor had to be less than 1. Okay? And we have this side is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So 1/2. Okay, and this question is a prelude to chapter 8. But the way to solve it right now with what you know, you'll know another way in chapter 8, is to just create your similar triangles and then set up your proportions. Okay, so I'm just going to draw two 90-degree angle triangles representing the small one and the big one. Does everybody see the big one?
Yeah.
It's this one. And there actually is a third right triangle. I have this small one here and this one here, right? So I'm going to fill in everything I know. I'm going to label this A, B, C, and D. So let's call this one the big one, this one the middle, the medium one, and this one the small one. I feel like I'm reading Goldilocks and the Three Bears now or something. Okay. The big one, this is the 90. The short leg is 12. The side opposite the 90 is 4 plus x. Does everybody see that? Yes. And I'm going to label this. This is A, this is B, and this is C. This one now, I want to make it in the exact same similar fashion. So the 90 here is here now at D. Everybody see that? And that corresponds to the 90 here. So I'm going to label this one D. Okay, and the short side is B, BD, the short side there, so this is B. And then the long side is AD. So this is A. And now this is in the right, what do I want to say? This is the short side, this is the short side, long side, long side. It's the right configuration. I don't have to rotate it or anything. This is similar to this. Okay. And I'm going to label this small one now. The hypotenuse is 12, and the short side is 4. Do I have enough, even without worrying about the small one, to go ahead and write some proportions now? I do. Because I have a short side in the hypotenuse, a short side in the hypotenuse. So I can say 12 over 4 is 4 plus x over 12. This simplifies to 3. Multiply, I get 36 is equal to 4 plus x. 32 is x. The key here was really figuring out your similar triangles and labeling the sides so you could see what ratios you have. We're going to learn a shortcut in Chapter 8 to solve a problem like this. But for now, all you have to work with is similar triangles. Does that make sense? All right. Test is tomorrow. And then NWA Monday or Friday. Monday, Tuesday. Tomorrow I'm going to hand out the chapter reviews. Or sorry, final reviews. Final reviews. I'll hand those out tomorrow. They will be due Monday. I will start going through them on Monday. I will emphasize this as I say it. I highly encourage you to do your reviews. Highly encourage you. Okay. I don't know. There's just going to be, I'm just telling you, I would do it.